Hello and welcome back to the channel. Today I'll be talking about how I implemented wall climbing in my Godot game. Here's the final product. So the player can walk on the floor. When he comes close to a wall, he can grab onto that. He can fall off the wall. When he comes close to a ceiling, he can grab onto that and fall off the ceiling. And he can grab onto surrounding objects when falling. Let me show you how I implemented this. What I used is basically a state machine on the player script. The reason why I need a state machine is because the player's possible actions are determined by where he is in the environment. So if he's on the wall, he can move up, down, and right to let go of the left wall. And those actions do different things depending on what the state is. Let's start out in the physics process, which runs every tick of the physics engine. And the first thing we do is process input. Here I split the states by available axes of movement. For ceiling and falling states, the player moves in the x-axis. So we affect the velocity x. And for the wall right and wall left states, the player moves in the y-axis, so we affect the velocity y. So moving up from the floor can bring you into the wall states, and the way we check if we can do that is with raycasts. Here's the player node. So we have raycasts going left, right, up, and down. There are two of them because there are tiny gaps in Godot tiles. So when the player would be on the ceiling and he comes into the gap between the tiles, he would just fall off it. Like I said, the player enters the falling state once he presses down on the ceiling, and this is where the state machine enter state function comes into play, because basically when the player starts falling, he's still technically in range to grab onto the ceiling. This is why on enter state we start a 100 millisecond timer that will not let us enter into a previous state. So when we enter a state, we save the previous state, and then we enter the new state. Start the timer, and if the enter state function is called again, and the timeout is not up, then the player will not enter the new state. So if the player was grabbing onto the ceiling and then he lets go, there's a 100 millisecond gap where he can't grab onto the ceiling again. If the player is in the wall stage during input, he can move up and down and move left and right to let go of the walls. So basically, if we're on a wall and we press right, we check if there is a ceiling or a floor next to the player with the raycasts. And if there is, then we changed him into either the floor or the ceiling state. If there is not, then we change the player into the falling state. So that was the process input function, and the next thing we do is process gravity. And gravity changes depending on the state as well. So if the player is on the left wall, then the gravity is pushing him left. And if the player is on the ceiling, then the gravity is pushing him up, and etc. In this case, gravity is a vector because I want to be able to add it directly to the velocity. So process input gets our movement velocity. Process gravity gets our gravity vector, and then we add the gravity vector to the velocity, and then we move the player. Process collisions is used for enemy and projectile collisions and is not relevant to the video. Thing that is relevant is update state, and what we do here is check if changes in the environment or the player position in the environment warrants a change in state. So if a player walked off a ceiling and there's nothing to grab onto, he starts falling. Or if the platform that the player is grabbing onto disappears, then the player is falling, right? Essentially, if none of the rays are hitting anything and the player is not dashing or falling, then he starts to fall. If the player is dashing or falling and one of the rays hits something, then he grabs onto it. And this is update state. Next thing is update animation. And this is where we change the sprite and its rotation depending on the state and a movement direction. So if the player is dashing, set the angle of the sprite and set frames to dash. If the player is falling, depending on whether he's falling directly down or sideways, set animation to that and set rotation to 0 in case he was dashing before. And if player is not dashing, not falling, and he's not idle, then he's walking, and we set rotation to 0. If the player is not moving and his velocity vector is 0, then he's idle, and we set frames to that. After that, we update the rotation. So if the player is on the left, well, we rotate the sprite by 90 degrees, and we flip it depending on the y velocity, if he's moving up or down. If the player is on the ceiling, then we set the rotation to 180, flip by x-axis. If he's on the wall right, then rotate to 70, flip by y-axis. If he's on the floor, set rotation 0, flip by x-axis. And if he's falling, set rotation 0 and flip by x-axis. This concludes the video. I will link the state machine tutorials that I used for my implementation, and I will see you next time.